So, welcome back, guys. We were going to move into the next lesson when Heather told me, and I quote, not changing one word of her exact statement, that, you know, the law of tangents looks uber mega cool, but, well, I understand it. I'm just afraid that some of our viewers might not be so keen on it, might have a little trouble with it. So I think that skipping over an example would have been, well, actually was a really, really bad idea. And, you know, how can I say that I won't give an example after hearing a speech like that? I mean, come on, wasn't that the most convincing speech you've ever given, word for word, recited to our viewers?
Oh, yeah. I must say, it was brilliant.
Yes, Heather is quite brilliant.
That's right.
So anyway, with her encouragement, I am going to be giving you guys an example for the law of tangents, even though I originally said that I wouldn't, because you'll almost never need it. So, as you may recall, the law of tangents simply said the following. Scary, scary statement. So after all the scariness and fear has been overridden by our explanation, everyone can be happy. So, Heather, usually when dealing with the law of tangents, you're going to have the angles A and B. Mm-hmm. What you're not going to have are the side lengths A and B. You're going to be missing one of them. Which one should I leave out?
B.
B. Okay. So I'm going to say that A is equal to 8. And capital A is equal to, I don't know. Let's say 30. And capital B is equal to 15. Well then, filling in what we know that 8 minus B divided by 8 plus B equals 10 of 1/2 of... Okay, what's 30 minus 15?
15.
And what's 30 plus 15?
45.
Exactly. So as we work this out, we're going to find out that the 10 of 7.5, which is 15 divided by 2, so 10 of 7.5 is roughly equal to, and again, I'm going to be doing some rounding. And 10 of 22.5, which is 45 divided by 2, is going to be roughly equal to... Now, 0.4 is slightly less than 0.5, which means we're expecting the numerator to just more than double, right? Because if you divide by 0.5, you're multiplying by 2. If you divide by something smaller than 0.5, you're multiplying by more than 2. Okay. So what we're going to do is we're going to say 10 of 22.5 divided by 10 of, 7.5? Does that sound about right?
Yep.
Equals 10. Oh, no, my bad. I reversed them. I'm like, that answer doesn't make any sense. 10 of 7.5, rather, divided by 10 of 22.5. Yeah, that answer makes a lot more sense. Equals 0.3178 ... Again, there's rounding. You can round to as much or little as you'd like, depending on how accurate and precise you want your answer to be. So I'm just going to move this whole thing up to increase my working space. So let's continue. So we have that... Oh, right, you need to grab the tool. Hey, look at that, it's still writing. Divided by 8 plus B equals 0.3178. This means, arrow, 8 minus B equals 0.3178 times 8 plus b. And if you're following along with your calculator, you might notice that my answers seem to be getting more accurate. Like, if I multiply 8 by 0.3178, the answer might not be exactly what I'm getting right now. That's simply because I had the previous numbers, 0.317837245 etc. in my calculator, and I simply multiplied that by 8, not the already rounded one that I'm working with on the whiteboard in front of you. So, by doing this, we get that 8 minus b equals 2.5427 plus 0.3178b. Do you see that, Heather? All I did was I distributed this number to multiply against both of these.
Yeah.
So far, so good.
Yep.
So now we go, what's 1b plus 0.3178b? Well, that's pretty clearly 1.3178b, right?
Mm-hmm.
And then equals, there's a b there. Make sure that's very clear. That's not a 6, it's a b. And 8 minus 2.5427 gives 5.4573. So again, once again, I'll just slide this whole thing up. And we have that 1.3178 times b equals 5.4573. You divide both sides by 1.3178, so that becomes a 1. So 1.3178, I believe the rest of it goes 32452 or some such. And you're going to get that b, when all is said and done, is equal to 4.1411. So that's how you'd use the law of tangents. So as you can see, it seems to be a lot of work. It actually is quite a bit of work. It's often, almost always, a lot quicker to use the law of sine or the law of cosine. But at least now you know how to work with the law of tangents. The reason I say it's almost always quicker to work with the law of sine or the law of cosine is simply that if you know A, capital A, and capital B, and you know either lowercase a or lowercase b, then it's very easy, for instance, to use the law of sines and say, well, lowercase, anyway, it's very easy to use the law of sines, because if I remember correctly, our numbers were a equals 30, b equals 15, perhaps lowercase a equals 8, but don't hold me to that, and we didn't know b. Well, a divided by sine A equals b divided by sine B. And I'm just going to check if that gives me the same answer. I believe it should if I have the right A. So a divided by sine A means 8 divided by sine 30, which gives 16. So 16 times sine B, and sine B would be sine of 15, which is times, I'll write sine B equals B. Sine B was 0.25881904551, so 16 times all that gives 1411 In fact, it's the exact same number we had above. So as you can see, we got the same answer for B in a lot less time.
Mm-hmm.
So does that make sense, Heather?
Yeah.
So can you see why you'd very rarely want to use the law of tangents, and much more frequently be able to use the law of sines or cosines in much less time?
Yeah.
Excellent. So with that, if Heather has no questions, we're going to wrap up this part of the lesson.
No, thank you, Demondo.
Excellent. Thanks a lot, guys.